Okay, all right, 2016, number 2. Here we go. For 2016, number 2, for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine of t squared divided by 2. The particle is at position x equals 2 at time t equals 4. Okay, so for part A, at time t equals 4, is the particle speeding up or is it slowing down? All right, so when is a particle speeding up? When is a particle speeding down? Or slowing down, I guess I should say. So for part A, what we need to do is we need to look at the sign of the velocity and the acceleration at time t equal 4. Okay? All right, so the velocity was given by this function. And I already put this function in my calculator. If I can use my calculator and I'm given any kind of function, the first thing I want to do is plug that into my calculator. So I've already put that into y1. Okay. All right, so the velocity at 4, I'm just going to go ahead and plug 4 into y1. So I'm going to get 2.978 for my velocity. 2.978. And then now the acceleration. So I go math 8. I'm going to take the derivative of the velocity being y1. So alpha trace y1 at 4. And I'm going to get negative 1.164. So my velocity is greater than 0. My acceleration is less than 0. Because they have different signs, the particle is slowing down at t equal 4 because the velocity is greater than 0 because v of 4 and a of 4 is less than 0. Okay? Because they have different signs, the particle is slowing down. Okay? Part B, find all times t in the interval 0 to 3 when the particle changes direction. Justify your answer. All right, so for part B, particle will change direction. Changes direction when what? When the velocity changes sign. Okay? So on my graph, I'm going to go over to my graph. I've already got the velocity as y1, but I do want to change my window. The window it says that we need to use is only between 0 and 3. So that's all I care about for my x values is 0 to 3. Okay, going by 1s, negative 10 to 10 should be fine. I'm just more concerned with when I change signs. So here's the graph. Okay. And I want to figure out when it changes signs. It looks like it changes signs at this point here. So to find that 0, I'm going to go second trace, 0, and I want to go on the left side of the 0. So I'll get as close as I can within reason, right? So I'm on the left side of the 0. So if here's my 0, I'm on the left, so I press enter. And then I want to go on the right side of the 0. As long as I'm beneath the x-axis, I'm good. So I'm on the right side, I press enter. For my guess, it doesn't matter. I just press enter, and I get 2.707. So at t equals 2.707, the particle changes direction. And we could kind of expand on this. We could say v of 2.707 equals 0 and changes from positive to negative. Okay? Okay. So let's take a look at part C. Find the position of the particle at time t equals 0. So for part C, I want to know the new position. So I need to figure out the position at zero. But it tells me the position is 2 at t equals 4. So x of 4 is equal to 2. Okay? So somehow I want to connect these two things together. I'm given the velocity, but I want to go back to my position. So if I take the integral of velocity, I will get my position function. And I want to use the numbers that I have here, the time intervals that I'm either given or trying to find. So this integral is going to go from 0 to 4. And I'll evaluate my position from 0 to 4. Okay? So if I take the integral of velocity from 0 to 4, that would be equal to the position at 4 minus the position at 0. Well, the position at 4 is 2, but I need to find the position at 0. Okay, so to solve this for x of 0, I'll add the x of 0 over. I'll keep the 2 there and then subtract the integral. So the integral from 0 to 4 of v of t dt. Okay, calculator problem, so we're just going to do this on the calculator. So 2 minus the integral, so math 9, 0 to 4 of the function, and then dx. Let's see if this works. Yep, negative 3.815. Okay, so that's the new position. So that's the position at x equals 0. Okay, for part D, I want to find the total distance the particle travels from t equals 0 to t equals 3. Now I know we didn't specifically talk about this in class, but from prior videos, do you remember when or how we would calculate the total distance the particle travels? Okay, if you don't remember, that's okay. It's the integral from 0. I want to find it, the total distance traveled from 0 to 3, so this is just the integral of the absolute value of your velocity function. And this is just calculator, so math 9, 0 to 3, absolute value, so math, go over to abs, type in your function, alpha trace y1, and then dx on the end. Okay, give it a minute to calculate it, and we should get 5.301, maybe. Yep, 5.301. Okay, so let's talk about the point breakdown for this one. For part A, you're going to get 2 points total. For the conclusion with the reason, it's kind of an all or nothing type deal. All right, so you can't have just part of it, you have to have all or nothing. So that's the conclusion with the reason. For part B, 1 point for t equals 2.707, and then 1 point for your justification, so talking about it equaling 0 and changing signs. Okay, so that's 1 point for that. For part C, 1 point for the integral, 1 point for the initial condition, x of 4, and then 1 point for your answer. For part D, 1 point for the integral, 1 point for your answer. Okay? All right, that's it.